Right. So in this demo, we discuss how A2A communication works. It is a relatively new topic, and not much has been discussed around this field of AI. Now, in A2A, basically, this is a way for AI agents to communicate with each other, either unidirectionally or bidirectionally. And this really becomes really important whenever we have systems that have to agentically do their AI things. And this comes in really handy when we have chat assistants that have to communicate that have to communicate to different agents from external sources or other remote environments. Now, to give this more in-depth sense, let's look at like a practical example. For instance, we have like an AirAsia agentic system. So let's say AirAsia has a right now they currently have a currency agent that deals with exchange rates for different countries, different nationalities. It sort of normalizes the currency for different locations. They also have a payment agent that deals with their CRM, or sort of their customer database or customer management system. And then pretty much this there are more MCPs connected to this agent, but for now let's consider like a CRM MCP for this. I don't know what's an MCP. Basically, an MCP is a module context protocol that allows AI agents to communicate to some system, right there. Let's say a Salesforce CRM, or a simple database. This MCP allows the AI agent to communicate with that database or that customer system. So that's the MCP basically. Just as a high level view. Now they also have a booking agent, which connects to their. Sorry, this should be a CRM as well. This could be done by the CRM as well. Also connects to the CRM MCP server. So the booking agent, tells the CRM that there's a new booking. Handle this properly. So they communicate through a defined schema. There's more onto that, but I will not go and dive deep into how MCP works. Basically, there are tools that the MCP server provides to the agent. The agent parses that and sends a request to that MCP server. It's basically a unified protocol as to how the agents can communicate to external systems or resources. Now with A2A, basically, now what we want to do is to let different agents bidirectionally or unidirectionally communicate with each other, because there are certain complex tasks that have to be delegated to different agents. Or let's say a certain payment agent has to communicate directly to a currency agent, or a booking agent has to communicate to a payment agent. There are instances, especially in a practical sense, that these agents would have to interoperate with each other. Now this is where A2A really comes into play, when a certain a general agent can delegate tasks to different agents, and then these agents will deal with their own implementations or business processes, and then we don't have to worry about that anymore because it's been delegated already by the AI agent. So it's pretty much really autonomous, in a sense that everything is driven by AI. There's almost no human intervention here because everything is autonomous, except for the development, of course. But that's pretty much the high level overview of how A2A communication works. Now to show you an example, we have here the A2A JavaScript SDK. This is pretty much our sort of blueprint, or this gives us the implementation and the schemas as to how we can implement A2A communication with our own systems. So let's say we have, for the case of AirAsia, we already have, suppose, an MCP available. Now, we want to set up these agents, or rather A2A servers, and then we want them to be able to communicate to an A2A client, or the general agent, right? So basically, an A2A server is our uh, A2A servers that deal with the MCPs. So these are really specialized AI agents that do their thing, you know. They're capable of doing their thing. And then these agents present themselves to the A2A client or the general agent by having what we call an agent card. Because how will the A2A client know that these exist, right? How would they know? How would the client, A2A client, know? So it's through an agent card that these AI agents broadcast to be discovered by the A2A client, right? So we define an agent card. You know, there's already a type for this from the A2A SDK, and then pretty much we just populate the type with these different fields: the name, description, the endpoint to which and where it exists, the provider, the version, it's what capabilities does it have, does it support streaming, meaning can I see how the agent works in real time. This is basically what streaming is. And then can it push notifications? This is really important for when a certain AI agent takes days to finish a task. We'd have to implement push notifications. And is the agent use history, right? And also other security schemes, let's say, you know, client ID enforcement or other security schemes you might have, and input and output modes for the agent in a general sense. Does it accept text, or and does it also output a text format, or does it accept a JSON or whatever? Could also be an image, could be anything. And then we also define what skills does that agent have. So let's say you can chat to it about movies, you know. It can give you the title about, you know, certain movies, you know, the plot or whatever, who's directed it. So pretty much this is what the AI agent does. You know, pretty much you define it in such a way that it makes sense for the general agent A2A client. Now, how do we manage the tasks delegated by the A2A client to these agents? How do these agents manage those tasks? Now, it's managed through an agent executor. Basically, this agent executor handles the everything that the agent needs to do. So it has an in-memory task store, the task store, the wrapper for it, everything. So to do this, we first sort of implement an interface called the agent executor. This interface is defined in our A2A SDK. Pretty much we just import it from the A2A SDK server inside the A2A.js module or library, sorry. And then pretty much we just implement the required methods that we need to do. And for our required methods, we only have two actually. So it requires us to implement, execute, and cancel task. So for the execute, we'll discuss on that later, but let's go through this step by step. So we create a class called myAgentExecutor that implements this interface, and then we define two variables. We first define a canceled tasks set, so everything here is unique. It's a set of strings where everything is unique. And then also a cancel task asynchronous method, which accepts two parameters, which has two parameters, a task ID and an event bus. Pretty much this event bus, this is literally this handles all the events. You can publish into this, you can push your updates here, or you can listen on this event bus, whichever you want to do. But pretty much this is where all events, are being held. So in this cancel task, it returns a promise. This is a JavaScript promise, and then you can resolve on this later, right? So let's say we want to cancel a task. So we provide it with the task ID, and then we use that task ID to push that task ID into our canceled tasks set. All right. And then the execute loop will be responsible for publishing the final state. So pretty much we don't have to worry about updating the event bus yet in this async function or method, because the execute loop will be the one responsible for it. So pretty much this execute method is just a loop basically that accepts a request context and an event bus as its arguments. So our request context pretty much has a text and a message, and then other artifacts and parts to it, and other components as well. But just to give you an overview as to what our core components are, we have a task, a message, an artifact, a part, and a push notification. Those are the core components. So, when we receive a sort of a message, that would be stored in the request context. This is what we call later on. So, when we receive request context, we can access the user message through the request context.user message, or we can also get the existing task in the request context.task. And then we determine the IDs for the task and the context from the request context. The task ID is pretty much auto-generated, and the context ID as well. Now, this comes from the request context, so you don't have to worry about it. But we see this in action later. So there's also a mechanism that Google recommends that if a certain task event is not existing in our existing tasks, then we create a new task. So how do we do this? So we need to publish something into our event bus, and then basically we just create an initial task, or anything, you can name it anything as long as it is of type task, and then you define its properties and then publish it into the event bus. So what's really important here is the kind. You need to specify that it is a task. Then you need to give it a sort of status. So what is the state right now of the task? And the state right now is submitted. It gets sent to the event bus, which handles everything later on. And then afterwards, after it's been submitted, we then publish a working status update. Now, if it's currently working on the task, we send a new kind, a status update. Notice that it's now not a kind of task, but rather a status update, since the agent is already working on it. And then we just pass it around the task ID and the context ID, and then other parts. Let's say, what is the update about? Oh, it's about generating the code. So pretty much in this status update, we basically have a message here. The message here is that it's generating code. That's it. And then what's really important as well is to set this final property to false, since it's still not finished. It's currently working on it, of course. Then we publish this update to the event bus. Then afterwards, we simulate the work. It's working on something. Then since this is a promise, we have to resolve that, right? So let's simulate the work. Let's say it's been working for 1 second. We resolve that promise to be successful, right? And then if the user wanted to cancel the request, we basically just check if that canceled task, since the user will push on the canceled tasks set, then we can just check if that canceled tasks has the task ID, then the request is canceled. We send a status update to the event bus saying that it's canceled, and then pretty much the event bus is already finished since it's been canceled. We also update, let's say the promise has been resolved. We publish an artifact update to our event bus, meaning that we now completed the task, and we can include, the final result for it. We can include it in the parts, Then finally, after that, we publish a final status. So let's say the agent has been finished with it. We say it's completed, and then set final to true, and then publish it. And then the event bus is finished as well. Now, these are just method implementations, and then we have to call this at some point. This is a class. This is not instantiated yet. So we need to instantiate this later on. Now, in our server, in the actual server implementation, we call that agent executor, our my agent executor. And then we set our request handler as well from our default request handler from A2A. A wrapper for the A2A agent using Express.js. And then we set up the routes for it. Pretty much all of this is just boilerplate. We set up the port. You can set an environment variable for this, or you can just hard code it, whichever you want. And then Express will listen on that port and forward the requests to the actual A2A server. Now pretty much it just acts as a wrapper, and then it just forwards it to the actual A2A implementation. But this is to provide you with an interface whenever you need it. Now, when we have the server done, what we now need to implement is the A2A client. The A2A client is basically now our general agent A2A API. Let's say it's an API. And it could be anything as long as you implement the A2A client. So we can just import the A2A client from the SDK, and then import the necessary types from the SDK commons. This is the commons folder. And then from some UUIDs for message ID generation, and your actual A2A client instantiation with calling the constructor using our A2A server endpoint. So this is our A2A server endpoint, as you can see, because this is based on how we set our agent card. So we have it at localhost 41241, and this is also what we put in our Express wrapper. So we have 41242. It really depends on how you want to do it, but it's up to you what port you want to use. But you can use 41241 or 41242 or even 3000, whichever you want. And then on that client, we can use this client instantiation to access the methods that A2A client provides from the SDK, right? So we define a function run. This is sort of your main implementation for your client. And then this is where you can send your messages to the A2A agent. So first, you define a message ID using a random UUID from the UUID library. Then just set up a global task ID variable, which will be set up later. You just instantiate this, and then you wrap your whole implementation around the try catch to handle error handling. And then inside the try block, you set up a send parameters variable of type message send params. Basically here, what we're going to do is we just define what we need to send to the agent. So what are our parameters to the agent? Now, you notice that it follows a strict schema. This is really important since we're using TypeScript. This is like how HTTP works. We have query parameters or URI parameters. Basically here we have message send parameters, right? So we give it a message ID from the UUID we randomly generated. And then what is the role of this message? Since this comes from the user, presumably, we send our message, like say hello agent, and then it's of kind message. Then is for the configuration, is it synchronous or is it async? Set blocking to true if it's sync. And then what are the accepted output modes? So we want a text plain, so because we're not requesting a certain JSON schema, so we can just say text/plain. Now for the send response, basically this is of type send message response, and then we just wait for the response of our send message. So this is more of a sort of result based. Not really the actual response of the AI agent yet. This is more of uh, you know what the status is, what the task ID is, and so on. And if there's an error, sending the message, handle it accordingly. If it's not, if there's no error, we look in through that result. So we set a result variable, const result is equal to send response as send message success response. So we basically cast it to this type and then get the result. So if the result is a task, the agent created a task, and then if that's the case, we get the result and cast it as the task, and we just log it, that saying our AI agent created a new task. If it's a message, then cast it as a message and then show the message result. Now, if a task was created, we want to get its status, right? So if the task ID is present, basically we create our get request parameters. So this is our task query params. So what do we need to request from our A2A protocol? So we send a get request for with a body containing a key ID and the value of that using the task ID from the send response, right? And then on our get response, basically we just wait as to what is the details about the task. So we just say client.getTask using the get params, and then it should give us the task result if it's present. So since this is blocking, this is not async, we can easily get the task result from here. So we just, if it's successful, we can cast it to get task response and then get the result and then log it into our console. If there's an error, there's a client communication error and so on. And let's run it. And there are also cases when the agent might take longer to respond, and we don't want our front end or our client side to feel awkward because they have to wait 15 seconds or 40 seconds for the AI to finish generating its response. So we can stream our communication with the AI agent using this implementation. Basically, what just changes here is that now we use stream params, message send params, it's sort of the same thing. And then we use a send message stream. Basically, this is how server send events work. Basically, you send a continuous connection from the client to the server, and the server continuously sends you updates. You just keep on listening. This is simpler than the usual WebSockets approach, where we have to set up and broadcast and other complex functionalities. This one is just sort of one way. So just listen for updates from the server and then parse it accordingly. So in our stream, we set up a stream. We instantiate. We utilize the send message stream method from the A2A client, and then we get the current task ID, which we will get later. And for each event in the stream, let's say we receive an event from the stream. We want to get the ID from it, since we're initializing a current task ID variable. So here, if we receive a task, we want to get the task ID and put it here. And then say task created, then continue. Skip the whole for loop. And if it's a status update, then we just log it as a status update event. If it's the final, then meaning the stream is now final, and then we want to exit the loop when the server says it's complete, since status event is already final. This is where it was really important to say when or not in the server we send a final update right here. So pretty much when we receive final, with a boolean final, we want to say that the stream is now final and we can proceed with other implementations, right? So in this case, it breaks the for loop. Now, if it is not a status update, but rather it is an artifact update, meaning we got a new artifact. So let's say there's an update with regards to the artifact. We pretty much just log it here. What is the length of the current artifact and others. Pretty much just to clarify you, artifact is the result of the AI agent. So this is the final thing, and this is where you usually listen to for updates in the front end or the client side, and we get updates on the artifact. And then if it's not an artifact, then we have a direct message response, and it's not a task, then we can say that we have received direct message, and then we say that the stream is finished, and then boom, we're done. That's all.